Caterpillar continuously looks for product improvements that allow greater efficiency for our customers. How will the machines of tomorrow be improved? Current strategies involve increasing horsepower and capacity, but these strategies are limited. As an alternative, can we apply cutting-edge automation to use these machines to their fullest extent? Caterpillar Research, together with the Robotics Institute at Carnegie Mellon University, has sought an answer to this question by developing core technologies for automated mass excavation. The Automated Loading System project, started in 1995, has developed a fully automated system to perform truck loading using a hydraulic excavator. The core technology from this product is now ready to automate portions of the loading cycle on many machines in our product line. In the near term, this technology will improve operator productivity. When a human operator performs an excavation task, he considers several questions. How should I position the machine to achieve the best performance? Where should I dig to maximize the bucket fill factor? Where are obstacles in the work site and how do I work around them? Where do I dump and what is the best way to get there? Today, operators answer these questions on every cycle. Do their choices always maximize productivity? Even the most skilled operators fatigue over a long work shift. What if the machine could be made smart to help the operator? Our technology promises to make this dream a reality. An operator's tasks can be divided into three main categories: perception, planning, and control. The Automated Loading System project has developed technology in each of these three areas. These key technologies are applicable across many Caterpillar machines. Perception is the ability of the machine to see and understand its surroundings. Planning is the ability of the machine to decide how to do the job and the best way to do it. Control is the ability to regulate the motion of a machine to perform the specified task. Let us examine the task of truck loading step by step. First, the machine must decide where to dig to maximize the bucket fill factor. Range sensors image the terrain and provide a topographical map of the work site. Using strategies similar to those of expert operators, the dig face is divided into multiple regions. There are no pre-programmed dig locations. In each region, hundreds of candidate dig locations and bucket attack angles are considered. Each is evaluated on the basis of expected fill factor, digging time, and expended energy. The best candidate is chosen. We have used AutoDig, an algorithm developed internally at Caterpillar, to execute the digging specified by the dig planner. During digging, the topographical map of the bench is used to ensure that a consistent bucket volume is captured. This allows digging to stop at the right time and efficiently fill the bucket with a consistent volume of material. If no acceptable dig locations exist, the system levels the floor or repositions the machine by tracking along the bench. Expert operators continuously adjust their digging strategy to the current soil conditions. Our system uses the shape of the terrain, bucket trajectories, and cylinder pressures to continuously estimate soil properties and maximize bucket fill. On many large machines, the operator is unable to determine when the bucket is full, and energy and time are wasted in continuing to dig. Alternately, operators trying to improve cycle times may underfill the bucket. A spin-off product from our system could provide feedback to the operator on the amount of material in the bucket, thereby improving productivity on each dig. Once a bucket is loaded, the operator must decide where to dump. Our system does this automatically. The shape of the payload is sensed, even with the dust and glare in this scene. Recognition software is used to recognize and locate the dump target, in this case an on-highway dump truck. A map of the dump target area is created by the range sensors. Truck features such as bed rails and canopy edges can be reliably identified to determine the truck's location and size. This recognition technology could be used to enhance wireless teleremote operation when visibility or depth perception are impaired. This technology could also be used to determine the height of the truck as a wheel loader approaches it, allowing the machine to automatically raise the bucket. This would free the operator to concentrate on other parts of the cycle, allowing him to be more productive. The same sensor information that is used to recognize the truck can also be used to determine the distribution and volume of the load in the truck and to decide where to dump the next bucket load. Here we see the motion improvement technology in action. Clearly, this loading pass is too slow and not very productive. The machine acts as if it is being operated by a novice, making simple, uncoordinated motions. Here is a much improved loading cycle that was found automatically by this motion planning technology. The machine motions are better coordinated and more fluid, as if operated by a skilled expert operator. This motion planning approach is able to adapt to the machine's unique work environment and is flexible enough to apply to a variety of loaders, trucks, and loading configurations. We have developed a design tool that uses machine simulation to determine the best way to perform a loading cycle. This technology can serve a key role in the design process of new machines, since the simulated machine can include proposed linkage and hydraulic system components, allowing comparison of various untested configurations. The motion evaluation can be based on time, energy, or smoothness of motion. During vehicle operation, safety is of primary concern. Caterpillar machines must perform their duties without endangering the people and equipment sharing their workspace. We have developed sensors that monitor the work environment for objects entering the workspace. Machine motion is stopped until the unsafe situation is resolved. Often, an operator's view of the workspace becomes obscured by dust, rendering him unable to see obstacles entering the region. We have designed environmentally sealed sensors that can operate in these severe conditions. This technology can be applied to many Caterpillar machines. A sensor mounted on the rear of a machine could detect obstacles and alert the operator. The technologies developed here could be used to provide feedback to operators today to help them become more productive. For example, a training aid for a loader on a large mining site could be used to improve operator skills. A customer could rotate his operators onto these smart training machines for a day of training each month. For example, the training machine demonstrates to the novice operator how to load a truck. When the operator is ready to try it, he takes over and attempts it himself. Let's watch the combined mass excavation core technologies in action versus a highly skilled operator. On the top half of the screen, Ron Fauber is operating a Model 325 excavator. The automated loading system is operating the same excavator on the bottom half. Can a machine keep up with a top operator? The automated loading system performed favorably with respect to a skilled human operator while loading material into the truck. It processes information and makes decisions on the go, just like Ron. While the performance of the operator tends to decrease over time due to fatigue, this system can continue at high productivity levels indefinitely. Let's summarize the possibilities for these key technologies: perception, planning, and machine control. Technologies developed for dig planning and perception-based dig monitoring can be used to calculate the material volume during digging and to determine the optimal load factor for front shovels, scrapers, loaders, and track-type tractors. As portions of these machines' cycles are automated, dig planning and perception will enable the machines to adapt to changing digging conditions. Technology developed for truck recognition and for determining the volume of material within the truck bed could be used for automating the process of dumping into a target. This could be limited to raising the bucket for a wheel loader operator, or automating the motion and dumping portion of a hydraulic excavator's loading cycle. Determining the volume of material in a dumped target could be used to determine the amount of material in the bowl of a scraper, or the amount of material being dumped into a trailer by a combine. Technology developed for motion planning could be used when the operator is remotely supervising the machine. It may be possible for one operator to remotely supervise several machines, which meets future customer needs caused by the shrinking availability of experienced operators. An automated motion planning system that matches the productivity of manned operation could also allow Caterpillar machines to be redesigned to further increase productivity by eliminating the operator's cab. Obstacle detection is useful in a host of applications in which operator visibility is obscured. From a fogged-out mine site to a cluttered construction yard, reliable and smart sensors would find their niche in making Caterpillar machines safer. The technologies that have been developed for the autonomous loading system will improve machine productivity and will enable the development of self-adapting machines that automatically complete portions of their work cycle while being supervised by an operator. Sensors that can function in harsh environments and advanced planning and perception software provide the customer with technology that supports Caterpillar's reputation of reliability. These technologies will enable the customer to realize his vision of being able to achieve high productivity with inexperienced operators and improved productivity with experienced operators. We are excited about this development done within the Technical Services Division and Carnegie Mellon University. We see many potential applications for spin-offs from this work, and TSD is ready to work with you to make it happen.